Let's take a look at some of these steps in creating a source file, creating an object file, and then creating an executable file. Okay, so let's take a solid example and we'll go over some of these steps. So what we need is a terminal. That's all we need. Plus we need all the compilers and the compiler tools and all that. And I think it's all up on your live DVD. So everything you need is pretty much on your live DVD, I believe. Let's just try it out. So first thing you need is VI. And let's just create create a source code. Let's create a C program. And you'll be doing a lot of this in this course. This will be, if you haven't seen it before, take a look. You get you'll get an overview of what is involved in writing a C program. Okay, so turns out you need to include certain programs. Oops, just noticed that VI understands C syntax, and so it's decided to use some colors that make it hard for you to see exactly what I'm doing. And so now what I'll have to do is change this so that you can see the text. Okay, that's better. All right, I hope this looks better. So you don't have to do this. I'm just doing it so that you can see the text as I type it in. So one thing that you'll need is all of the stuff in C that deals with standard input and output. So writing to the screen, taking input from the keyboard, all of that is in here. All of that basic code is sort of set up in there. And then the simplest program that you can set up is just a main, just like public static void main in Java. Same idea. And let's just print out a simple message. Oops, you need a printf. Hello, Csis 248. This part might look pretty familiar to Java programmers because printf was something that C programmers liked so much. When they switched to Java, they said, well, we really should have printf in Java too. And so Java did not have printf and then later got it because so many people liked it. All right, I'm just taking a look here to see if this is all we need. I think this is all we need. So I just used VI to edit and put in 5 or 6 lines of code. And this should print out a simple message on the screen, okay? So I'm gonna WQ. I'm not sure if this is bug-free or error-free. We'll find out. So the first thing you want to do is compile it down to object code. You don't have to, but you can. So here's how you do that. You say GCC for the new C compiler. And I'll say just compile it down to object code xyz.c. And I think I might not have to say what I need, what I want to call it. So let's just try that. GCC -c xyz.c. So I created a C program using VI, and now I'm going to compile it down. Let's see what it did. So it looks like it did nothing. If you do an ls-l, you see that there is an xyz.c, and although it didn't say that when I did this, it created an xyz.o. Notice the size. The C program is tiny, 78 bytes. This is almost, well, it's more than a kilobyte. So it goes up quite a bit. It takes the C program, generates object code, and you can try to take a look at it. No, people don't usually do it, but when you get started, sure. Or let's just, the thing that I'm worried about is that if you list the contents of xyz.o, it usually messes up your terminal because there's all this machine language instructions in there. So let's try it out. We can deal with it. So if you list xyz.c, you get regular ASCII text, right? Stuff that you've edited before, just ASCII code. But if you cat xyz.o, okay, so now, okay, my terminal is still working. Sometimes you might cat out an object file and your terminal just stops working. You have to start up a new terminal. Okay, so we're safe. So notice that this is all mostly stuff that you can't really read. There is some things you can see here. So yeah, so here's part of our code. Here's some other strings. All right. So now, can you run this? Turns out no, you cannot run this xyz.o file. So you can look at the characteristics of these files. You can say file xyz.c, tells you that it's ASCII text. File xyz.o tells you that this is basically executable code. And we'll go over some of the details of what all of these things mean later on. It's in ELF format. Okay, so can you run this? No. You have to do one more step, and you have to call the link loader. And it used to be that you had to use LD, the LD command, and that's what people did for a long time. But now it's a lot easier, and you have a lot fewer things to specify if you just use the GCC compiler directly. And it knows that it should create an executable file. So now I'm going to say, well, so you have an option here. You can say, I want to name the output file. And typically you would call it something like XYZ. In Linux, you don't need anything like .exe, which you would find in Windows. You don't actually need that executable, that exe file extension for executable files. So what I'm going to do is I'm going to take the default actually for now. So I'm going to say gcc xyz.o. So I created an ASCII file, ASCII text file called xyz.c using vi, compiled it down to object code, and now I'm going to create an executable program from this. So once again, it looks like it didn't do anything, but if you say ls -l, what you will see is a file called a.out. The book says it will become a.exe, but I think they're using a slightly different system. Notice that a.out is quite a bit bigger even than xyz.o. So from a 78-byte C program, you generated a 7K or 7,000 byte executable program. That's not bad. A lot of times you'll see even bigger executable files. Okay, so what can you do with this executable file? You can actually run it because that contains machine language instructions. So how do you run it? You say, look in the current folder directory for a.out and just run it. Notice the permissions. It has X in the 3 locations for permissions, meaning that it's an executable file. Okay, so a.out, you run it, and you get exactly what you put in the printf. So once again, cat xyz.c. All we wanted it to do was print out this message, and sure enough, here it is. So there you go. Try it out. Set up a program, whatever, .c. Use GCC to compile it down to object code, use the -C option and you can see the object code. You can remove, once you're done with creating the executable, you can remove xyz.o. You don't need it anymore. And now all you need is, oops, the source code. You don't want to remove that usually. You want to keep it around, and executable. So let me remove a.out, and I'll show you the other thing that you can do. So normally what you would do, if all you're doing is writing one file and just compiling it, you can do this, gcc, and specify the name of the executable file if you want to. If you're, if you want to have multiple executables, yeah, you want to do that. So you want to say, okay, my source code is xyz.c. I'm going to create an output file called xyz, which is going to be the executable file. And this time around, I'm not going to generate object code. I'm not going to use the -C option. I'm going to go straight through. Actually, it goes through the steps of creating object code and then the executable, but then it wipes out the object code itself. GCC will do that automatically if you do this, xyz.c. So this is saying GCC is compile xyz.c and create an output file called xyz, which should be an executable. Usually you don't get anything unless you have errors in your program. Luckily, we didn't. Okay, so take a look at this, xyz.c, and then xyz, no object code. It actually did create an object code temporarily and then wiped it out. Notice program is, as before, the size of the program is about 100 times bigger than the source code. Not bad. And you can run it. xyz. And it runs. So try this out. If you're not sure how to write C programs, no big deal. We will be doing this many times the rest of the semester. Okay, and then next up we'll go back to our notes and look at things like ideas about object code and executable code in a lot more detail.